we introduce RigGS, a new paradigm to model articulated objects from videos without relying on additional template priors. Given a monocular video, we can model the object for novel view synthesis, as well as for easy editing, driving, and reposing. As no template prior is utilized, this is a challenging task. Previous work, SECs, employs a 3 Gaussian representation with sparse control points and Arab terms for editing dynamic objects. However, its controllability is limited, making it challenging to edit actions reasonably. Hence, we propose a new method to assemble a skeleton for the 3 Gaussian representation to facilitate easy editing. Initially, we modeled the dynamic object through 3 Gaussian splatting with a skeleton-aware node-controlled deformation model. This step involves obtaining skeleton-aware nodes used for constructing the skeleton. Subsequently, we propose a skeleton-driven dynamic model to rig the skeleton with the 3 Gaussians. This enables editing of the dynamic object by adjusting the skeleton's pose. For initialization, we establish a skeleton-aware node-controlled deformation model. Rotations and translations are associated with these nodes, and the deformed 3 Gaussian can be obtained by combining the node transformation. We render the deformed Gaussians and optimize the consistency with the input image. In addition, we also project the nodes onto the plane and make them close to the 2D skeleton points through the projection loss. This process yields initial 3 Gaussians, dynamic fields, and skeleton-aware nodes. Next, we select a deformed shape as a more physically meaningful canonical shape. After uniformly sampling these nodes and constructing a minimum spanning tree, we remove unnecessary branches through merging and removal steps, ultimately obtaining a sparse skeleton using a heuristic algorithm that integrates geometric, motion, and semantic information. Through these steps, we build a skeleton-driven dynamic model. We introduce linear blending skinning-based coarse deformation with learnable skinning weights and pose-dependent detail deformation, enabling the editing of dynamic objects via new skeleton poses. In the following, we present the result. We initially compare editing performances with ApeNerf, a template-free neural point cloud representation for articulated objects. Subsequently, we assess novel view synthesis performances with various dynamic modeling methods. Additionally, our method supports motion transfer. To aid editing, we develop a GUI, or real-time interactive editing, to generate new actions. Our method also demonstrates good performance on real collected data.